Okay, let's talk about clipping. Clipping is what happens when your signal is stronger than what your audio interface can represent, or when what your DAW can represent. Nowadays we are using floating point numbers to represent sound, and clipping is not really an issue until you use something non-linear or until you send your sound to the sound card. But anyways, sometimes it's useful to clip the signal. And yeah, we have a nice clipper now in Alpha Forever, but anyways, I'm gonna show you the most basic method of clipping. So we are going to build a naive clipper now. And for that, we are going to take the absolute value of the signal, so we will only work with the upper part. And here we will simply say that if this signal is stronger than 1, then we will output 1. If it's not stronger than 1, then we will output the absolute value. Let's also divide the absolute value by the signal itself, like this. And this division gives us the sign of the sound. So if it was positive, then it gives us +1. If it was negative, then it gives us -1. If it was exactly 0, then we get 0. So this way, if we multiply the this if operator, then we get our signal back, but this is already clipped. So these values can go above 1 now. So what we can do is let's put a stereo track here for simplicity's sake, and boost it by 6 decibels. And here you have aliasing. The only frequency that's not aliasing here is the root frequency of 7,000 Hertz, and this is the first dot harmonic, which is 21,000 Hertz. So all the rest of the harmonics that you can see here are results of aliasing. So let's put these into a designer. And this is the input, this is the output. Yes, it works. And actually we don't need to clip that hard, so actually this much would be enough. And you can see this this did not cause that much harm. So if we just wanted to lower the dynamic range and remove that heavy transient, I think even this is okay. And if we divide by the linear gain, then we can see that we are just removing the upper part. This is the naive clipper. We have also a hard clipper, and let's take a listen on what the hard clipper does. Let's take a look at it. Let me remove this division so the two signals are equal in power. And the hard clip AA uses infinite linear oversampling. The signal is a lot cleaner. So you can compare the blue with the naive clipper, and the yellow is the infinite linear oversampling clipper, and this is a significant difference. So, and then we have the clipper node. Let's plug this in. I'm not going to use the drive now because of we drive it using this function. And let's take a look at the difference now. The blue signal is going to be the clipper. So let's take a look at it, and this is beautiful. All the aliasing is gone. Basically we have only one visible peak. Yeah, okay, there is some aliasing here, but that's really minor. But this introduces a bit of delay. So this has a group delay of 0.1567 milliseconds on my system. It depends on the sample rate. Thanks for watching, and if you want more content like this, then please subscribe and share this video and leave a comment and all the stuff. So happy noding, bye bye.